Good evening everyone. Good evening. I welcome you all again to the NEET Elite. Hope you guys are doing great, having the good time. Well people, let me know in the chat box if I'm audible and visible to everyone. Yes, finally Wassim Sir is back, yeah? Let me know in the chat box if I'm audible and visible to every single guy right here. Good evening. Welcome back guys, welcome back after so long, yeah? Welcome back. Let me know in the chat box with the thumbs ups if I'm audible and visible to everyone. Yes. I'm doing good, Rohan. I'm doing good. How are you guys doing? I'm doing great. Better than before, yeah. Perfect, guys. Perfect. Yes, Yashwani, I remember you. Absolutely, I remember everyone. How can I forget my elites? Yeah. All right, Anjana, I'll be taking a separate session on that as well. No issues. Yes, Priya, I remember. Absolutely. Thank you, Ananya. Thank you. Thank you, Ashwarya. Thank you so much. Thank you. Well, people, as you all must be knowing, in the today's session, we are going to do the chemical equilibrium. Yes. Well, I have come up with around 25 questions by means of which your whole chemical equilibrium will get revised. And I'm sure you would have seen the schedule of the week, which I'll be following throughout. Yes, just go through that once. You'll get the idea of what all topics, what all chapters we are going to cover in this week, yeah? Perfect. So before starting the session, guys, let me introduce myself for the ones who do not know me. My name is Wassim Sir and I'm your chemistry master teacher right here. All right, so people, let me know how many of you appeared for the V.O.T.E examination. Just give me the thumbs ups in the chat box. I just want to see how many of you actually appeared in the 3 attempts of the V.O.T.E. Just let me know fast. I just want to see it. Let me know fast. Hi Rishi, how are you doing? How many of you attempted for this Vedantu Online Talent examination? I just want to see it. Perfect. All right, guys. So as you all must be knowing, there is only one attempt left for this Vedantu Online Talent examination. So I want you guys to register for that because you are going to get a lot of benefits if you will register for this, if you will qualify this, okay? You are going to get the scholarships, right? Best prizes you guys are going to get, and you guys will get a chance to become the CEO of Vedantu for a day, yeah? Like a CM for a day, right? Perfect, guys. Perfect. So the last exam is going to be on 18th of April. So do register for that. And how to register for that, I'll be letting you know that. Just give me a second. This is something which you'll be already knowing. Yeah. So people, what you guys are going to do is you need to register and create the voter ID and you need to choose your voter days, and only this session is left. Sunday, 18th April 2021, right? This is the 4th examination of the V.O.T.E. So do register for this and shoot the bullseye, as I always say, with us. Yeah. Perfect. All right, let's get to know the exam format for the ones who are going to write the 11th part. Okay. Well, I'm going to talk about the Pcb exam pattern. You'll be having total of 90 questions, and in those 90 questions, there will be 22 questions from the physics part, 22 questions from the chemistry, and 46 questions from the biology portion. Yeah. And marking pattern is going to be same as that of your NEET, right? +4 in the correct one and -1 in the incorrect one, right? And you'll be having 90 minutes for the test. So this was the exam format for the ones who are going to write the 11th portion, okay? Now for the 12th portion, for the same PCB, again, you'll be having 180 questions in total, out of which there'll be 45 questions in your physics, 45 questions in your chemistry, and 90 questions in your biology, right? And the marking pattern is going to be same as that of your NEET, +4 and -1, and there'll be 180 minutes in total for the examination, right? Arusha, organic, we are doing that as well. Well, tomorrow I'm going to take the hyperconjugation. That was lecture number 10, I guess, of GOC, right? Well, I have shared the schedule. You just check it out. You'll be getting the idea of what all things we are going to cover this week, yeah? All right, so for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, right? Okay, so people, let me know in the chat box if you guys are ready to rock again with me right here on NEET Elite. Let me know fast. Let me know, are you guys super duper excited for the session or not? Let me know fast. Let me see the josh of the session as I always used to see before starting the session, yeah? Perfect, guys. Perfect, perfect, perfect. Perfect. So people are super duper excited for it. Yes? Exactly, Abila. The team is back. The team is back. Yes. All right. So I have called this series, which I'm starting today, as Zero to Hero series, wherein I'll be brushing up all the chapters which we have already done, okay, through the questions. As I told you earlier, I have come up with around 25 questions. By solving those 25 questions, your whole chemical equilibrium chapter is going to get revised. Yes? So let's get started with the first question, which is on your screen now, okay? Well, people, as per the question is concerned, we are given with the Kp value for the reaction N2 gas plus 3 times H2 gas is in equilibrium with 2 times NH3 gas. Yes, we are given with the Kp value for the reaction as 49. We are going to calculate the value of Kp at the same temperature for the reaction which is right here, okay? For this reaction, I'm going to calculate the value of Kp. I'm sure you guys are going to kill this question if you have watched the entire video lectures of the chapter Chemical Equilibrium. If not, so let's get started with the basics. Well, guys, as per the characteristics of equilibrium constant is concerned, I have told you in earlier as well, I've told you whenever we reverse a reaction, its equilibrium constant is inversed. Its equilibrium constant is inverse. I hope you remember this, yeah? Whenever we reverse a reaction, its equilibrium constant is inversed, yeah? For example, I've got a reaction like this, A in equilibrium with B. Let's assume its equilibrium constant I'm representing by KEQ. Now, people, if I'll reverse the reaction like this, B in equilibrium with A, what is going to be the new equilibrium constant for this reaction? It's going to be 1 divided by KEQ. This is the first thing which I want you guys to remember. On reversing the reaction, its equilibrium constant is inversed. Yes? Perfect. Now, at the same time, one more important thing. Whenever a reaction is multiplied by some number, whenever I'll be having a reaction which will be at equilibrium, if I'll multiply that reaction by some number, that number goes to the power of the equilibrium constant. I hope you remember that as well. What do I mean by this? Let's say I've got the reaction A in equilibrium with B, whose equilibrium constant is KEQ. Now, if I simply multiply this reaction by 2, that this number 2 goes to the power of equilibrium constant like this. Now, the new equilibrium constant for this reaction is going to be KEQ square. Similarly, if I would have multiplied the reaction by 1 by 2, it would have become something like this, 1 by 2A in equilibrium with 1 by 2B, and whenever I multiply a reaction with some number, that number goes to the power of equilibrium constant, so I can say the new equilibrium constant for this reaction is going to be K equilibrium raised to power 1 by 2. Well, this is the concept which I'll be using in this question right here, so let's try to solve it, right? Perfect. See, guys, the reaction which is given to me as, I'm given with the reaction N2 gas plus 3 times H2 gas. It's in equilibrium with 2 times NH3 gas, yeah? This is the reaction which is given to me, and its equilibrium constant Kp is given to me as 49. We are going to calculate the value of Kp for this reaction at the same temperature, right? Okay. Now, what I'll be doing right here is I'll be making this reaction from the given reaction, okay? I'm going to make this reaction from the given reaction right here. And how I'll be making that? First of all, if I'll simply reverse this reaction, it's going to become like this, 2 times NH3 gas in equilibrium with N2 gas plus 3 times H2 gas, right? On reversing the reaction, as I told you, its equilibrium constant is inversed. Now, what is going to be the equilibrium constant for this reversed reaction? It's going to be 1 divided by 49, right? Now, people, if I multiply this reaction by 1 by 2, it's going to become like this, NH3 gas. It's in equilibrium with half of N2 gas plus 3 divided by 2 times H2 gas, right? And since I've multiplied the reaction, I've multiplied this reaction by 1 by 2, that 1 by 2 will go to the power of the equilibrium constant like this. So it's going to be 1 by 7. So people, I have made the reaction whose equilibrium constant I was supposed to calculate, right? And its equilibrium constant is going to be 1 by 7, okay? So let me know in the chat box how many of you got it right. Let me know in the chat box how many of you got it right. I just want to see how many of you killed it, right? Let me know fast. Let me know fast. Let me know fast in the chat box. I just want to see it. Perfect, guys. Perfect. Perfect. All right. That means you remember a lot of things, yeah? Perfect, guys. Great. Okay, so this was the concept number 1, which we have discussed right here. Okay, that was the characteristics of equilibrium constant. So remember from now onwards, whenever we'll be reversing the reaction, its equilibrium constant will be inversed, number 1. Whenever a reaction is multiplied by a certain number, that number goes to the power of equilibrium constant, number 2. On adding the reactions, their equilibrium constants are multiplied. Remember that as well. On adding the reactions, their equilibrium constants are multiplied. Okay, perfect. Let's move on to the second question, which is on your screen now. Well, guys, this is the very simple question. Again, okay, I'll be exactly starting from the basics of how to solve this sort of equation. Well, I'm given the reaction A gas plus B gas in equilibrium with 2 times C gas. 2 moles of A, 1 mole of B and 1 mole of C are present in a 10-liter vessel and allowed to reach equilibrium. If the concentration of C is 0.2 molar, then calculate the value of Kc. Okay, let's see how this question is to be solved. Understand properly what I'll be saying. See, guys, I'm going to write the reaction like this. We have got a reaction A gas plus B gas. It's in equilibrium with 2 times C gas. This is the reaction which is given to me as per the question. Well, guys, I'm given with some data as per the question, and what is that data going to be? At time t is equal to 0, when the reaction has not started, I'm given with 2 moles of A, I'm given with 2 moles of A, 1 mole of B and 1 mole of C. Okay, so at time t is equal to 0, when the reaction has not started, I'm given with 2 moles of A, 1 mole of B and 1 mole of C. Okay, so C is already in the container in which the reaction is going to take place before starting. Okay, so before starting the reaction, I have got C with me. Okay, now what is going to happen? Now what is going to happen? Understand. See, guys, let's assume at equilibrium, out of 2 moles of A, X moles of A have reacted with B. Let's assume at equilibrium, out of 2 moles of A, X moles have reacted with B. So I'll be having 2 minus X moles of A still left in the container at equilibrium, right? Now, guys, I'll be using the normal stoichiometry. Since we know from the stoichiometry of the reaction, 1 mole of A reacts with 1 mole of B. So I can say X moles of A would have reacted with X moles of B. And I had 1 mole, and out of 1 mole of B, X moles have reacted. So I'll be left with 1 minus X moles of B still in the container at equilibrium, right? And already in the container, I had 1 mole of C. Now, few more moles of C would have got formed when this reaction would have started. Yes. Now, again, use the stoichiometry. I can say 1 mole of A gives 2 moles of C. So X moles of A are going to give 2 X moles of C like this, yeah? So I got the number of moles of each reactant and product right here at equilibrium, right? Perfect. Now, people, what am I supposed to calculate basically? I'm supposed to calculate the value of Kc, okay? And how do I write the expression for Kc? I hope you remember that. Expression for equilibrium constant Kc is going to be concentration of C at equilibrium raised by the stoichiometry coefficient, that is 2. Concentration of C at equilibrium raised by 2 divided by concentration of A at equilibrium raised by its own stoichiometry coefficient, that's 1, multiplied by concentration of B at equilibrium raised by its stoichiometry coefficient, that's 1. Yeah, this is something by means of which I can calculate the equilibrium constant. Okay, right? Now, people, what else am I going to do? Since I got the moles of each reactant and product right here at equilibrium, but do I need the moles of reactants and products at equilibrium, or I need the concentration of reactants and products at equilibrium? I need the concentration of reactants and products at equilibrium, right? Yes. And how do I convert moles into concentration? I just divide the moles by the volume of the system. I get the concentration. Now, people, as per the equation, I'm given with the volume of the vessel as 10 liters. So I'm going to divide this term by 10. I'm going to divide this term by 10. I'm going to divide this term by 10. So I can say I got the concentration of each reactant and product right here at equilibrium. Okay, these are the concentrations of each reactant and product at equilibrium, correct? Now, one more term is given in the equation. If the final concentration of C is 0.2 molar. So people, the final concentration of C as per the reaction, as per equilibrium, is 1 plus 2x divided by 10. And it's mentioned the final concentration of C. That means concentration of C at equilibrium. It's given to me as per the equation as 0.2, or instead of 0.2, I can write 2 divided by 10. Yes, I hope you guys are clear with this, right? Now, what is the concentration of C at equilibrium? It's 1 plus 2x divided by 10. This value is equal to 2 divided by 10, right? 10 and 10 will get cancelled out. So I'll be getting the value of x right here as 1 by 2. That means 0.5. So I got the value of x. I got the value of x, right? Now put the value of x right here in these terms. I'll be getting the exact values of concentrations of each reactants and products right here. Okay. Well, guys, it's going to be like this. Have a look. It's going to be 2 minus x. What is the value of x which I got? I got the value of x as 0.5. 2 minus 0.5 is going to be 1.5 divided by 10. Well, this is the concentration of reactant A at equilibrium. Similarly, 1 minus 0.5, that is 0.5 divided by 10. This is the concentration of B at equilibrium. 1 plus 2x divided by 10. It's simply given to me as 0.2 as per the equation itself, right? Concentration of C at equilibrium, 1 plus 2x divided by 10. It was given to me as 0.2, okay? So people, I got the concentration of each reactant and product right here at equilibrium. I'm going to place all these values in this expression. I'll be getting the value of equilibrium constant Kc right here, okay? Well, guys, the concentration of C at equilibrium I got to know as 0.2, so it's going to be 0.2 ka square divided by concentration of A at equilibrium I got to know as 1.5 by 10, right? It's 1.5 divided by 10 multiplied by concentration of B at equilibrium I got to know as 0.5 divided by 10. So can you let me know the exact value of Kc which you'll be getting after doing the calculations? Can you let me know in the chat box? Can you let me know? Can you let me know fast? Can you let me know its exact value which you'll be getting after doing the calculations? Well, Priya is saying it's 16 by 3. All right, I trust you. So the value of Kc right here is going to be 16 divided by 3, which I was supposed to calculate right here. Can you let me know in the chat box if you got it right? Can you let me know in the chat box if you got it right? I want every one of you to say it. Just let me know fast if it's clear. Yes, V enthuse. And by the way, I teach V enthuse as well, yeah? I hope you remember. Perfect, perfect, guys. So should we move on to the next question? I hope this concept is clear to everyone. Should we move on to the next question right here? Should we move on to the next question? Just give me the thumbs ups. Yeah? Well, I can understand a bit of Tamil, but I cannot speak. Konjam terima. All right, guys, perfect. Let's move on. Let's move on to one more question, which is going to make one more concept of yours clear. Okay. Well, guys, this is the question on your screen. This is the question on your screen. 1 mole of N2 and 3 moles of H2 are placed in 1 liter vessel. Find the concentration of NH3 at equilibrium if the equilibrium pressure is 1 atm and equilibrium constant Kc at 400 Kelvin is 4 by 27, right? This is one more question which we guys are going to do right here, okay? And this is going to make your one more concept clear. Let me show you how. See, guys, first thing, as you all must be knowing, when N2 reacts with H2, it leads to the formation of NH3, right? That's all which all of you must be knowing, yeah? See, guys, I've got the reaction as N2 gas plus 3 times H2 gas. It's in equilibrium with 2 times NH3 gas, yeah? This is the reaction which is given to me, okay? Now, people, at time t is equal to 0, when the reaction has not started, I'm given with 1 mole of N2. I'm given with 3 moles of H2, okay? And that means there will be no product right here at time t is equal to 0 which would have got formed because the reaction has not started yet, yes? N2 has not started reacting with H2 yet, right? Now, people, at equilibrium, let's assume out of 1 mole of N2, let's assume X moles of N2 have reacted with H2, right? So at equilibrium, I'll be having 1 minus X moles of N2 still left in the container, right? Now, guys, use the stoichiometry. Understand properly what I'll be saying. Use the stoichiometry. 1 mole of N2 reacts with 3 moles of H2. So X moles of N2 are going to react with 3X moles of H2, right? And I had 3 moles of H2 and 3X moles have reacted. So I'll be left with 3 minus 3X moles of H2, right? Now we use the stoichiometry again. Since 1 mole of N2 gives 2 moles of NH3, so X moles of N2 are going to give 2X moles of NH3 at equilibrium. So people, I got the moles of each reactants and products right here at equilibrium. This is something which I got till now, yeah? I got the moles of each reactant and product right here at equilibrium, correct? Well, people, am I given with the volume of the container? Yes, I'm given with the volume of container as 1 liter. So if I'll divide all these 3 terms by 1, I'll be getting the concentration of each reactant and product at equilibrium, which is going to be same because the volume of the container is 1 liter. So 1 minus X is going to be the concentration of N2 at equilibrium. 3 minus 3X is going to be the concentration of H2 at equilibrium. 2X is going to be the concentration of NH3 at equilibrium, right? Perfect. Okay, is there anything else which is given to me? What am I supposed to calculate? Okay, I am given with the equilibrium constant Kc value, that's 4 by 27. And I'm supposed to calculate the concentration of NH3 at equilibrium. That means I need this value. I need to get the value of 2x. Well, 2x is the concentration of NH3 at equilibrium, which is what I'm supposed to calculate, okay? Now, people, let me write the expression for equilibrium constant Kc. It's going to be simple. It's going to be concentration of NH3 at equilibrium raised by the stoichiometry coefficient, that is 2, divided by concentration of N2 at equilibrium raised by its stoichiometry coefficient, that is 1, multiplied by concentration of H2 at equilibrium raised by its stoichiometry coefficient, that is 3. Yeah? Well, I know the concentration of NH3 at equilibrium. How much that is? That is 2x. So it's 2x ka square. It's 2x square. Instead of 2x square, I'm going to write directly as 4x square. Yeah? It's 4x square divided by. What is the concentration of N2 at equilibrium? It's 1 minus x. It's 1 minus x multiplied by. What is the concentration of H2 at equilibrium? It's 3 minus 3x. It's 3 minus 3x raised by the stoichiometry coefficient, that is 3, is equal to. Well, guys, this equilibrium constant Kc is given to me as per the equation as 4 by 27, right? 4 divided by 27. Well, I can do the normal mathematics. I can say 4 and 4 will get cancelled out. So what I'll be left with, understand. See, guys, it's going to be something like this. X square divided by 1 minus x, I'm writing as such. 1 minus x, I'm writing as such. If I'll take 3 out of this, okay, if I'll take 3 out of this cube, it will come out as 27, right? It will come out as 27, or let me write that 27 right here in the beginning, okay? And I'll be left with 1 minus x raised by 3, something like this. I've taken 3 cube out of the brackets. Yes, it's going to be 27, and it's going to remain as 1 minus x raised by 3 is equal to what? Since 4 already is cancelled out, it's 1 divided by 27. So 27 is altogether cancelled out. So I'll be left with x square divided by 1 minus x raised by 4 is equal to 1. Or else I'll be writing it as x divided by 1 minus x square whole raised by 2 is equal to 1. This is something which I got till now. Yeah, this is something which I got till now. Correct? Yes, Ashma, I'll be doing the atomic structure also. Just wait for it. I'll be doing that. No issues. Alright, so I got this equation till here. Okay, now people, I need to do a little bit of calculation. I'll be getting the value of x. Okay, and how's that calculation going to be? Just take square root on both the sides. It's going to be x divided by 1 minus x ka square. It's going to be 1, right? Or I can write x divided by, it's going to be a square plus b square minus 2x, right? It's going to be 1 plus x square minus 2x is equal to 1. Or else I'll just use bit of mathematics. It's 1 plus x square minus 2x, right? Or I can write it as x square minus 3x plus 1 is equal to 0. Well, guys, you got the quadratic equation, and I hope you know how to calculate the roots of the quadratic equation. It's going to be minus b plus minus root of b square minus 4ac divided by 2a. From there, you'll be getting the value of x. And once you get the value of x, you'll put that value of x right here, and you'll be getting the concentration of NH3 at equilibrium, right? So let me know in the chat box if you got the concept. Okay, let me show its exact value. Well, you're on solving this equation, you're going to get the value of x something as 0.381, and just by putting the value of x in the given equation, you'll be getting the value of 2x, and 2x was the concentration of NH3 at equilibrium. Let me know in the chat box if the concept is clear to everyone or not. Let me know in the chat box with the thumbs ups, right? Perfect, Darshini. Got it. Got it. Well, John Peter, this week only I'll be starting the inorganic as well. Well, I have already shared the schedule on my Instagram, on this channel, everywhere I've shared the schedule of the week. You can just check the schedule. You'll be getting the idea of what all chapters we are going to cover in this week, yeah? Darshini, the pressure is given just to confuse you, that's it. Surely, Shri, I'll be doing that. Yeah? I'm sorry. Okay. Well, guys, one more question which is given to us, and this question is again going to revise one more important concept from the chapter equilibrium. Yeah? I'm given with a reaction as N2 gas plus 3 times H2 gas in equilibrium with 2 times NH3 gas. Yeah? The partial pressure of N2 and H2 are 0.8 atm and 0.4 atm at equilibrium. The total pressure of the system at equilibrium is 2.8 atm. Calculate Kp for the reaction. Yeah? This is the question which is given to me. How do I approach this sort of equation? Again, it's a very simple and conceptual one. See, people, how do I approach this sort of equation? Understand properly what I'll be doing. I'm given with the reaction as N2 gas plus 3 times H2 gas. It's in equilibrium with 2 times NH3 gas. Yeah? This is the question which is given to me. 2 times NH3 gas. Right? Okay. The partial pressure of N2 and H2 at equilibrium are 0.8 and 0.4 atm. Okay. The total pressure of the system at equilibrium is 2.8. Calculate Kp for the reaction. First thing, how do I write the expression for Kp? Kp expression for the reaction is going to be partial pressure of NH3 at equilibrium raised par the stoichiometry coefficient of NH3, that is 2, divided by partial pressure of N2 at equilibrium raised par stoichiometry coefficient, that is 1, multiplied by partial pressure of H2 at equilibrium raised par the stoichiometry coefficient, that is 3. Yeah? So in order to calculate the value of Kp, I should know all these terms. I should know the partial pressure of NH3 at equilibrium. I should know the partial pressure of N2 at equilibrium. I should know the partial pressure of H2 at equilibrium. Well, do I know all these terms? No. I'm just given with the partial pressure of N2 and H2 at equilibrium. So this term is given to me, this term is given to me. I do not know this term. I do not know this term. And people, at the same time, I'm given with the total pressure of the system at equilibrium. Now, how do I solve this sort of equation? Understand. See, guys, understand the basic concept. Well, first thing, this reaction will be taking place in a container. Yes, absolutely. This reaction will be definitely taking place in a closed container, I must say, right? At time t is equal to 0, can I say I'll be having only reactants N2 and H2 in the container? Okay, at time t is equal to 0, when the reaction wouldn't have started, okay? So whatever pressure of the container will be there at time t is equal to 0, that pressure will be due to N2 and H2 itself at time t is equal to 0, right? Yes, at time t is equal to 0, whatever pressure of the container will be there, that's going to be due to N2 and H2, correct? Now, with time, when the reaction will start, can I say number of moles of N2 and H2 will start to decrease and number of moles of NH3 will start to increase? Yeah. If the number of moles of N2 and H2 will start to decrease in the container once the reaction starts, I'll say the contribution of N2 and H2 towards the total pressure is also going to decrease. Yeah. If the number of moles of N2 and H2 in the container are decreasing with time, I'll say contribution of N2 and H2 towards the total pressure will also start to decrease. Yeah. Now, people, there will be a time in the reaction when equilibrium will be established, okay? And once equilibrium is established in the reaction, I can say the number of moles of each reactant and product will be fixed, will be constant. And if the number of moles of reactants and products are getting fixed, are getting constant, I say the contribution of N2, the contribution of H2, the contribution of NH3 towards the total pressure, that's also going to become fixed, that's also going to become constant, right? What am I given with the equation? Can I say at equilibrium I'll be having a mixture of gas in which I'll be having few moles of N2 left, few moles of H2 left, and few moles of NH3 that would have got formed at equilibrium. So at equilibrium, actually I have got the gaseous mixture. Yeah. And what is the pressure? What is the total pressure of the gaseous mixture at equilibrium? That's given to me as 2.8 atm, right? The total pressure of the gaseous mixture at equilibrium, it's given to me as 2.8 atm. Well, as per Dalton's law, the total pressure of the gaseous mixture is always the sum of partial pressures of each gas in the mixture, right? Right? So I can say, instead of total pressure, I can I can write like this. It's going to be equal to partial pressure of N2 at equilibrium plus partial pressure of H2 at equilibrium plus partial pressure of NH3 at equilibrium. This value is given to me as 2.8, right? Yes. Perfect. Well, people, what is the partial pressure of N2 and H2 given to me? It's 0.8 and 0.4. All right. This term is given to me as 0.8 atm. This term is given to me as 0.4 atm. So I'll be getting partial pressure of NH3 from here. Can I say it's simply going to be partial pressure of NH3 is simply going to be 1.6 atm? Yeah. Well, guys, I got the partial pressure of NH3 at equilibrium and I already have the partial pressure of N2 and H2 at equilibrium. Yes, I have all the terms. Can I put all the terms in this equation and I'll be getting the value of Kp right here? Well, guys, after putting all these values into this equation, I'll be getting the value of Kp as 50. Okay. What is going to be the unit of this Kp right here? What is going to be the unit of this Kp right here? It's going to be atm to the power delta Ng. I hope you remember, right? Units of Kp, general way, atm to the power delta Ng. And what is the value of delta Ng for this reaction? It is number of moles of gaseous products minus number of moles of gaseous reactants. So 2 minus 3 plus 1, 4. So 2 minus 4, that's going to be minus 2. So it's going to be atm raised to power delta Ng, and delta Ng is simply minus 2. So this is something which I was supposed to calculate, right? Can you let me know in the chat box if it's clear to every single year writer? Can you just let me know fast? Can you let me know fast if it is clear to everyone? Perfect. Perfect, guys. Perfect, perfect. That's wonderful. That's wonderful. I really liked it. Okay. Let's then move on to one more question which is on your screen now. Okay. One nice question it is. A nice question it is, I must say. Yeah. Well, guys, what is given in the question and what are we supposed to calculate from the question? Well, in this question, the calculation part is a bit lengthy, okay? So no need to worry about that. In your actual NEET examination, calculation part will be very easy, but the concept might be same, okay? But in this question, calculation part is a bit lengthy, okay? So you must cooperate with that, right? All right, so people, 0.15 moles of carbon monoxide are taken in a 2.5 liter flask. Fine, I've got a 2.5 liter flask. In that flask, I've got 0.15 moles of carbon monoxide. Yes, it's maintained at 500 Kelvin with the catalyst so that the following reaction takes place. Okay, the reaction is, let me write the reaction again. The reaction is supposed to be carbon monoxide plus H2 gas. Is it H2 or 2 times H2? It's 2 times H2 gas. It's in equilibrium with what? It's going to be in equilibrium with CH3OH gas, right? This is the reaction which is going to happen in the container right here. Okay? See, guys, hydrogen is introduced until the total pressure of the system is 8.2 atm and okay, at equilibrium, and 0.08 moles of methanol is formed at equilibrium. Calculate Kc. See, guys, see what is given in the question and what are we supposed to calculate. We are first thing, we are going to calculate the value of Kc. Okay, we are going to calculate the value of Kc, and I'm sure all of you must be knowing how to write the Kc expression right here. Isn't it going to be concentration of CH3OH at equilibrium raised to power 1 divided by concentration of CO at equilibrium raised to power 1 multiplied by concentration of H2 at equilibrium raised to power 2? That's going to be the expression for Kc right here. I'm sure all of you must be knowing that. Yeah, perfect. Now, guys, at time t is equal to 0, understand properly what is mentioned in the question. At time t is equal to 0, I have 0.15 moles of carbon monoxide in the container. So basically, I'm given with a container. In that container, at time t is equal to 0, I have just got 0.15 moles of carbon monoxide. Yes? Now, people, as per the question, in that container which has 0.15 moles of carbon monoxide, I'm going to introduce H2 gas. And I'm going to introduce H2 gas until the total pressure of the system at equilibrium becomes 8.2 atm. I'm going to introduce the H2 gas until the total pressure of the system at equilibrium becomes 8.2 atm. Let's assume I had to add A moles of H2. Let's assume I had to add A moles of H2 in the container, then only the total pressure of the system at equilibrium became 8.2 atm. This is something which I'm assuming, okay? For example, in in the container which already had 0.15 moles of carbon monoxide. Let's assume I had to introduce A moles of H2, then only the total pressure of the system became 8.2 atm at equilibrium. This is something which I'm assuming right here. Okay, now see, since I have mentioned right here as time t is equal to 0, so at time t is equal to 0, there'll be no product because the reaction has not started yet. Okay, now at equilibrium, let's assume out of 0.15 moles of carbon monoxide, let's assume X moles of carbon monoxide would have reacted with H2, okay? So can I say I'll be left with 0.15 minus X moles of carbon monoxide at equilibrium in the container? Yeah, perfect. Now guys, I can use the stoichiometry as we always do, yeah? 1 mole of carbon monoxide would have reacted with 2 moles of H2. Yes, 1 mole of carbon monoxide reacts with 2 moles of H2. So I can say X moles of carbon monoxide would have reacted with 2X moles of H2. Since I had A moles of H2 in the container, so out of A moles of H2, 2X moles of H2 would have reacted. So I'll be left with A minus 2X moles of H2 in the container at equilibrium, right? Perfect. Now can I say 1 mole of carbon monoxide gives 1 mole of CH3OH? So X moles are going to give me X moles of CH3OH right here in the container. So can I say I got the number of moles of each reactant and product at equilibrium? Correct? Yes. Now people, if you got to know the number of moles of each reactant and product right here at equilibrium, can I calculate the total moles of the reactant and product in the container at equilibrium? I can do that. I can calculate the total moles present in the container at equilibrium. It's going to be 0.15 minus X plus A minus 2X plus X. This X and X would have got cancelled out. So I'll be left with 0.15 plus A minus 2X. So I can say these are the total moles present in the container at equilibrium, right? These are the total moles present in the container at equilibrium. Yes. Now guys, understand one more thing. The total pressure of the system at equilibrium is given to me as 8.2 atm. So these are the total moles present in the container at equilibrium, and due to these moles, the total pressure of the system at equilibrium is going to be 8.2 atm, which is mentioned as per the question. Well, people, am I given with the volume of container as well? Yes, I believe that, right? Volume of the container is given to me as 2.5 liters. Yeah. Volume of the container is given to me as 2.5 liters. Am I given with the temperature of the system as well? Let's check it out. Am I given with the temperature of the system right here? Yes, I'm given the temperature of the system as 500 Kelvin. Okay, I'm given with the temperature of the system as 500 Kelvin. Okay. Now, people, at equilibrium, I have got total these many moles present in the container. So I can use the ideal gas equation at equilibrium. I can do that. Yes, I can say P multiplied by V is equal to nRT. What is this P? P is the total pressure of the mixture which is present at the equilibrium. V is the volume occupied by the mixture at equilibrium. This N stands for the total moles present in the system at equilibrium. R is the gas constant and T is the temperature of the mixture at equilibrium. Yes, absolutely. Now people, since I have got the pressure, I have got the volume, total moles are given to me. Total moles are given to me as 0.15 plus A minus 2X. R value I can take as 1 divided by 12 or 0.0821. Temperature is given to me right here. Well people, if I put all these terms right here in this equation, I'll get the total moles at equilibrium, I guess, as 0.5. And already I know the total moles at equilibrium is equal to 0.15 plus A minus 2X. This is something which I already knew, yeah? And people, we forgot one thing. As per the question, it was mentioned that 0.08 moles of methanol are there in the container at equilibrium. And moles of methanol at equilibrium is equal to the value of X. So the value of X is given as per the question, that is 0.08, right? Well, people, if I put the value of X right here in this equation, can I get the value of A from here? Yes, I can get the value of A. Well, if I get the value of A and X, already I know. X I already know. If I get the value of A right here from this equation, I can just put the value of A and X in these terms right here. I'll be getting the exact moles of each reactant and product at equilibrium. Yes, I can do that. Correct? I hope you're following this. See guys, what I'm saying right here is I got the equation 0.5 is equal to 0.15 plus A minus 2X. 2x, x value we know, 0.08. So 2 multiplied by 0.08 is 0.16, yeah? So from here, it's going to be 0.5 is equal. It's going to be minus 0.01 plus A, okay? Or I can say A value I'll be getting as 0.51. A value I'll be getting as 0.51. Well, I have the value of A, I have the value of X. I'll just put the values of A and X in these terms right here. It's going to be 0.15 minus X, 0.15 minus 0.08. Isn't this going to be 0.07? So these are the moles. These are the moles of carbon monoxide at equilibrium. It's going to be A minus 2X. A value we know. This is 0.51 minus 0.16, right? 2X. 2x is 0.16, right? It's going to be 0.35. So I got the moles of H2 present in the container at equilibrium, and X value already we know that is 0.08. These are the moles of CH3OH present in the container at equilibrium. Since I got the moles of each reactant and product at equilibrium, these are the moles. This 0.07, these are the moles of carbon monoxide present in the container at equilibrium. These are the moles of H2 gas present in the container at equilibrium. And these are the moles of CH3OH present in the container at equilibrium. Well, people, if I got the moles of each reactant and product right here at equilibrium, what I'll be doing? I'll be dividing these moles by the total volume of the container. I'll be getting the concentration. Yes. So what I'll be doing after this? After this, I'll be dividing these moles of reactants and products by the total volume of the container, that is 2.5 liters. I'll be getting the concentration of each reactant and product at equilibrium. And once I get the concentration of each reactant and product at equilibrium, I can simply write the expression for Kc. And expression for Kc is going to be concentration of CH3OH at equilibrium raised by the stoichiometry coefficient, that is 1, divided by concentration of carbon monoxide at equilibrium raised by 1, multiplied by concentration of H2 at equilibrium raised by 2. Yes, and I have all the values. Yes, right? So concentration of CH3OH at equilibrium is going to be 0.08 divided by what is the volume of the container? That's 2.5. This is the concentration of CH3OH at equilibrium, whole divided by concentration of carbon monoxide at equilibrium. It's going to be 0.07 divided by what? Divided by volume of the container, that's 2.5. Raised by stoichiometric coefficient, that's 1, multiplied by concentration of H2 at equilibrium was 0.35 divided by volume, that is 2.5 raised by 2. This is something which you can calculate, and you'll be getting the value of Kc, which I was supposed to calculate, right? Let me know in the chat box if everything is clear till here, so that I can move on to the next question, which is going to make your one more concept clear. Let me know in the chat box with the thumbs ups. Let me know in the chat box. Yes, Shiva, class timing is changed. From tomorrow, I'll be taking the class at 7:30. Okay, 7:30 is going to be the new timing of the session. It's not going to be 11 from now onwards, okay? It's going to be 7:30 in the night. I hope that's perfect for everyone. Yeah? Hi, Nikhil, what's up? Long time, bro. Yeah, 7:30 is perfect, yeah? Rahil, I'll be starting chemical bonding this week itself, okay? Okay, let's move on to one more question. Let's get our one more concept sorted from one more question. See guys, this is one more question which is given to us, okay? And I'm sure you can easily solve this one as well. I'm sure about that. Well, I'm given the reaction as AB3 gas in equilibrium with AB2 gas plus half of B2 gas. If the initial pressure of AB3 is 900 torr and the total pressure at equilibrium is 1000 torr, calculate Kp. We are supposed to calculate the value of Kp, yeah? Well, let me write the reaction first of all. It's going to be AB3 gas in equilibrium with AB2 gas plus half of B2 gas. Well, this is the reaction which is given to me, yeah? Okay. If the initial pressure of AB3 is 900 torr, at time t is equal to 0, can I say first of all, this reaction will be taking place in a closed container. And in that closed container, at time t is equal to 0, I'll be only having reactant AB3 with me. Yes. Right? At time t is equal to 0, I'll be only having reactant with me. So whatever is going to be the pressure of the container at time t is equal to 0, that's only going to be due to this AB3. And that initial pressure of the container, that initial pressure of AB3 is given to me as 900 torr. Okay. So people, I hope you remember I have taught you one important concept. We can treat the pressure the same way as we used to treat the moles, right? Correct? I hope you remember that. We can treat the pressure the same way as we used to treat the moles, okay? So this is the initial pressure of AB3 which is given to me, that's 900 torr. This is going to be 0, this is going to be 0. Now treat these pressures the same way as we used to treat moles, okay? So at equilibrium, can I say it's going to be 900 minus X. So this is the pressure of AB3 at equilibrium, which I call as partial pressure of AB3, right? This is going to be X and this is going to be X by 2. I hope you remember this, yeah? So I got the partial pressure of each reactant and product at equilibrium, correct? Yes, I got the partial pressure of each reactant and product at equilibrium because I have treated the pressures in the same way as we used to treat the moles, yeah? Exactly. Perfect, perfect. Now guys, understand what is given in the question. The total pressure of the mixture at equilibrium is 1000 torr. Well, the total pressure at equilibrium, the total pressure of the mixture at equilibrium is given to me as 1000 torr. Yeah, this is something that is given to me. Let me write it like this, 1000 torr, okay? Now people, few minutes back, I told you the total pressure of the mixture will be the sum of partial pressure of each. Yes. So the total pressure of the mixture will be equal to partial pressure of AB3 at equilibrium plus partial pressure of AB2 at equilibrium plus partial pressure of B2 at equilibrium, correct? So it's going to be 900 minus X plus X divided by 2. This value is given to me as 1000 torr, correct? Okay, so people, can I say this X and this X would have got cancelled out? So the value of X right here I'll be getting as 200 torr. So I got the value of X, and if I got the value of X, just put the value of X in these given terms. It's going to be 900 minus 200, that's 700. So I got the partial pressure of AB3 at equilibrium as 700 torr. Similarly, I got the partial pressure of AB2 at equilibrium as 200 torr. I got the partial pressure of B2 at equilibrium as X by 2. X is 200, 200 divided by 2 is 100 torr. I got the partial pressure of each reactant and product at equilibrium. Well, if I got the partial pressure of each reactant and product at equilibrium, what can I do? I can simply write the expression for Kp, yeah? I can write the expression for Kp as partial pressure of AB2 at equilibrium raised power 1 multiplied by partial pressure of B2 at equilibrium raised power its stoichiometry coefficient, that's 1 by 2, whole divided by partial pressure of AB3 at equilibrium raised power stoichiometry coefficient of AB3, that's 1, correct? Yes, I can do that. Now guys, what is the value of Kp which I'll be getting? I have got all the values. Whatever values I need in order to calculate Kp, I have got all the values. I have already calculated these, yeah? So people, the partial pressure of AB2 at equilibrium is going to be 200 torr multiplied by the partial pressure of B2 at equilibrium is going to be 100, and it's going to be 100 raised power 1 by 2 whole divided by partial pressure of AB3 at equilibrium is 700 torr. I guess you'll be getting the value of Kp from here as 20 divided by 7 because I saw a lot of people writing as 20 by 7 in the chat box. So I believe it's going to be 20 divided by 7 right here. Can you let me know the units of Kp? Can you let me know the units of Kp? Well, Kp, the general units of Kp are going to be atm to the power delta Ng. What is the value of delta Ng for the reaction? It's going to be 1 plus 1 by 2, that means 3 by 2. 3 by 2 minus 1 is going to be 1 by 2. So it's going to be atm to the power delta Ng, and the delta Ng value is 1 by 2. This is the value of Kp which I was supposed to calculate as per the equation, right? Let me know in the chat box. Oh, it's not atm, it's torr, yeah? Is it given as torr? Yes, okay. So it's going to be torr raised power 1 by 2, correct? Okay, let me know in the chat box if it is clear to everyone so that I can move on to the next concept, next question, which will make your one more concept clear. Yes, Nikhil, you can call me, bro. No issues. Yeah, let me know in the chat box if you want me to move on to the next question. Jagdish, I'm better, bro. Yeah, perfect. Let's move on to one more question which is on your screen now. Okay, let's see how this question is to be solved. The total pressure at equilibrium is 30 atm. All right, I'm given the total pressure at equilibrium is 30 atm, and the partial pressure of HNO3 at equilibrium is 2 atm. Calculate Kp for the reaction. This. Okay. See guys, I'm given the reaction. Let me write the reaction again. It's given as 4 times HNO3 gas, 4 times HNO3 gas. It's in equilibrium with 4 times NO2 gas plus 2 times H2O gas plus O2 gas, yeah? Plus O2 gas. Just check it out. Is the reaction balanced? It is 4, 3, 12. It's going to be 8 plus 2 plus 2. Yeah, the reaction is balanced, yeah? The reaction is balanced. Now, what we are supposed to calculate as per the equation? We are supposed to calculate the value of Kp. And in order to calculate the value of Kp, I should know the partial pressure of each reactant and product at equilibrium. Now, how am I going to do that? One more important thing that's mentioned in the equation, the pressure of HNO3 at equilibrium. That means the partial pressure of HNO3 at equilibrium is given to me as 2 atm. This is one more data which is mentioned as per the equation, okay? And I'm going to get the value of Kp right here, okay? See guys, let's assume at time t is equal to 0, the pressure of HNO3, that is P0, for example, at time t is equal to 0. This is going to be 0, this is going to be 0, this is going to be 0. As I told you, I'm going to treat the pressures in the same way as I used to treat the moles, yeah? Correct? Now guys, at equilibrium, I must say the partial pressure of HNO3 is going to be P0 minus X. Okay? The partial pressure of HNO3 at equilibrium is going to be P0 minus X. Now use the stoichiometry. Since 4 moles are giving 4 moles, 1 mole should give 1 mole, so X moles should give X. Okay? So this X is the partial pressure of NO2 at equilibrium. Similarly, it's going to be X by 2. Similarly, it's going to be X divided by 4. I got the partial pressure of each reactant and product at equilibrium right here. Okay? I got the partial pressure of each reactant and product at equilibrium right here. Okay? Well guys, what is mentioned in the equation? I'm given with the partial pressure of HNO3 at equilibrium. Since we know the partial pressure of HNO3 at equilibrium is P0 minus X. Yeah? The partial pressure of HNO3 at equilibrium, partial pressure of HNO3 at equilibrium is given to me as, it's given to me as how much? It's given to me as 2 atm. And we know the partial pressure of HNO3 at equilibrium, that is simply P0 minus X. So I got one equation as P0 minus X is equal to 2. Well, at the same time, one more thing. The total pressure at equilibrium is given to me as 30 atm, yeah? The total pressure at equilibrium. Can I say total pressure of the mixture at equilibrium is the sum of partial pressure of each? Absolutely, I can say that, right? So I can say P0 minus X plus this X plus this X by 2 plus this X divided by 4, it's given to me as 30. It's given to me as 30, yeah, as per the equation. The total pressure of the mixture at equilibrium is given to me as 30 atm, correct? Now, this term P0 minus X, as per the equation, it's equal to 2. So it's going to be 2, and take this 2 on that side, is going to be 30 minus 2, that means 28, okay? Just take the LCM on this side, it's going to be 7x divided by 4, yeah, is equal to 28. Right? So the value of X which you'll be getting, it's going to be 16 atm, right? So I got the value of X. I got the value of X just by solving this equation, okay? I got the value of X. People, if I got the value of X, I'm done with the equation, right? See, P0 minus X, that's the partial pressure of HNO3 at equilibrium. It's given to me as 2. It's given to me as 2, right? It's given to me as 2. So I got the partial pressure of HNO3 at equilibrium as 2 atm, correct? Well guys, X value we got now is 16. So 16x, I mean see, this X is the partial pressure of NO2 at equilibrium, that is 16 atm. Partial pressure of H2 at equilibrium is X by 2, that means 16 divided by 2, that means 8 atm. And this is going to be 16 divided by 4, that means 4 atm, correct? I got the partial pressure of each reactant and product right here at equilibrium. I can simply write the expression for Kp. Kp expression is going to be partial pressure of NO2 at equilibrium, that means 16, raised power stoichiometric coefficient, that is 4, multiplied by partial pressure of H2 at equilibrium, that is 8, raised power 2, multiplied by partial pressure of O2 at equilibrium, that is 4, raised power stoichiometric coefficient, that is 1, divided by partial pressure of HNO3 at equilibrium, that is 2, raised power stoichiometric coefficient, that is 4. Now you can just solve it out. You can get the value of Kp, which I was supposed to calculate, right? Can you let me know in the chat box if this concept is clear to everyone? I just want to see how many of you got it. I just want to see it. I just want to see it. Hello everyone. Hello, welcome. Yes, let me know if it's clear to everyone so that I can move on to the next one. Yes, Gayatri, as per the question, H2O right here is in gaseous state, okay? Perfect. Okay, let's then move on to the next question, which is on your screen right here. Calculate the Kp for dissociation of 1 mole of PCl5, which is 20% dissociated, with the total pressure at equilibrium as 1 atm. So before solving this question, let me give you the basic concept of how do we deal the equations of Kp and Kc in terms of alpha, in terms of degree of dissociation. Okay, understand. Let's say I'll go to the reaction as A gas in equilibrium with 2 times B gas plus 3 times C gas. Let's say this is the general reaction. Let's assume at time t is equal to 0, I have got A moles of reactant. This is going to be 0, this is going to be 0. Let's assume the degree of dissociation of this reaction, the degree of dissociation of A right here at equilibrium is alpha. Okay, so I can say at equilibrium, out of A moles of reactant, A alpha moles would have got dissociated into product. So I'll be left with A minus A alpha. I hope you remember this, right? These are the initial moles of reactant, and out of A moles of reactant, A alpha moles of reactant would have got converted into products. So I'll be left with A minus A alpha moles of reactant at equilibrium. Okay. Now, since 1 mole gives 2 moles, so A alpha moles are going to give me 2 A alpha moles. Similarly, 1 mole gives 3 moles, so A alpha moles are going to give me 3 A alpha moles of, this is 3 times B, right? Sorry, 3 times C. 3 times C gas. So I got the moles of each reactant and product at equilibrium, correct? Yes, I hope you know this. Yeah. Right? Perfect. Now guys, see how this question is to be solved. I'm going to use the same type of concept which I shown you right here in this question which is mentioned right here on the screen. Understand how this question is to be solved. Calculate the value of Kp for the dissociation of 1 mole of PCl5. Okay, first of all, you should know when PCl5 gas undergoes dissociation, it gets converted into PCl3 gas plus Cl2 gas. I'm sorry. Okay, this is the reaction which is given to me. PCl5 gas in equilibrium with PCl3 gas plus Cl2 gas. Calculate the Kp for the dissociation of 1 mole of PCl5. Okay, so at time t is equal to 0, I'm given with 1 mole of PCl5. This is going to be 0. This is going to be 0. Okay, and at equilibrium 20% of PCl5 has got dissociated into products. Okay, so let me tell you first of all, percentage dissociation is always equal to alpha multiplied by 100. Am I given with the percentage dissociation of PCl5 as 20%? Yes. So I can get the value of alpha right here as 20 divided by 100 is going to be 0.2. I got the value of alpha. Yeah. Now people, at equilibrium, if alpha is the degree of dissociation, it's going to be, this is the value of A first of all, right? A is equal to 1 as per the equation. So it's supposed to be A minus A alpha. A minus A alpha, so I can put the values directly. It's going to be 1 minus alpha, right? Similarly, it was supposed to be A alpha. Since A is 1, so it's going to be alpha. It's also going to be alpha. So I got the moles of each reactant and product right here at equilibrium. Yes. Well guys, can you let me know the total moles present in the container at equilibrium? So total moles present in the container at equilibrium are going to be 1 minus alpha plus alpha plus alpha. So total moles at equilibrium in the container is going to be 1 plus alpha. That is the sum of the moles of each reactant and product at equilibrium. Yes. Now guys, if I divide this 1 minus alpha with this 1 plus alpha, over here I'm again dividing with 1 plus alpha. Over here I'm again dividing with 1 plus alpha. Can I say I got the mole fraction of PCl5 at equilibrium? Can I say this is the mole fraction of PCl3 at equilibrium? This is the mole fraction of Cl2 at equilibrium? Yes. Well, the total pressure at equilibrium is given to me as 1 atm. If I simply multiply this term by 1, if I simply multiply this term by 1, if I simply multiply this term by 1, which is the total pressure, can I say mole fraction of the component multiplied by total pressure? It gives me the partial pressure of this reactant at equilibrium. I got the partial pressure of PCl3 at equilibrium. This is the partial pressure of Cl2 at equilibrium. Since I got the partial pressure of each reactant and product at equilibrium, I can simply write the expression for Kp. Yeah. But before that, do I know the alpha? Yes, I know the alpha, 0.2. Put the value of alpha in these terms. It's going to be 1 minus 0.2, that means 0.8, divided by 1 plus 0.2, that is 1.2. So this is the partial pressure of PCl5 at equilibrium, which is going to be 2 by 3 at the end. Yeah. Alpha we got to as 0.2, 0.2 divided by 1.2. This is the partial pressure of PCl3 at equilibrium. This is again 0.2 divided by 1.2. This is the partial pressure of Cl2 at equilibrium. You can simply solve these. It's going to be 4 by 3. Yeah, it's going to be 1 by 6. It's also going to be 1 by 6. You got the partial pressure of each reactant and product at equilibrium. You can just calculate the value of Kp. You can write this expression. It's going to be partial pressure of PCl3 at equilibrium, that is 1 by 6. Raised by its stoichiometric coefficient, that's 1, multiplied by partial pressure of Cl2 at equilibrium, that's again 1 by 6, whole divided by partial pressure of PCl5 at equilibrium, that is 4 by 3. You can just solve it out, get the value of Kp, which I was supposed to calculate. Can you let me know in the chat box if it is clear to everyone or not? Can you let me know in the chat box with the thumbs up? Yeah? Just let me know in the chat box if it's clear to every single guy. Let me know in the chat box if it's clear to everyone. Perfect, perfect, perfect. Perfect, guys. Let's move on then. Let's move on to one more question, which is going to make your one more concept clear. The degree of dissociation of N2O4 at 1.5 atm and 2.5 degrees centigrade is 0.25. Calculate Kp for the reaction N2O4 gas in equilibrium with 2 times NO2 gas. Okay, how this question is to be solved, understand. Well guys, the reaction which is given to me as per the question, that is N2O4 gas in equilibrium with 2 times NO2 gas. Yeah, this is the reaction which is given to me. And people, as per the question, the degree of dissociation, that's alpha. Alpha at equilibrium is given to me as 0.25. 0.25 means 1 by 4. Yes, this is the value of alpha which I'm given with, right? Either you write 1 by 4 or 0.25, whatever is convenient for you. And the total pressure at equilibrium is given to me as 1.5 atm. So total pressure at equilibrium is given to me as 1.5 atm. What am I supposed to calculate? I am supposed to calculate the Kp for the reaction. And in order to calculate Kp for the reaction, I need the partial pressure of reactant and product right here at equilibrium. Yeah? Hi Kishore, Vanakkam. Okay, see guys, for example, at time t is equal to 0, I have got A moles of N2O4 in the container. This is going to be 0, yeah? Well, if alpha is the degree of dissociation, at equilibrium, I must say, I'll be having A minus A alpha moles of N2O4 left at equilibrium in the container. Yes? Now use the stoichiometry. 1 mole gives 2 moles, so A alpha moles are going to give 2 A alpha moles. Yes? So I got the moles of each reactant and product right here at equilibrium. Okay. Well guys, after getting the moles of each reactant and product right here at equilibrium, can I get the total moles present in the container at equilibrium? Can I say total moles present in the container at equilibrium is going to be A minus A alpha plus 2A alpha, which is going to be A plus A alpha, right? Just divide this by A plus A alpha. Just divide this by A plus A alpha. Can I say I got the mole fraction of each reactant and product at equilibrium? Yes. I got the mole fraction of each reactant and product at equilibrium. If I multiply the mole fraction of reactant at equilibrium by the total pressure of the container at equilibrium, that is 1.5, I'll be getting the partial pressure of each reactant. So, I got the partial pressure of N2O4 at equilibrium. Similarly, multiply this term by 1.5, I got the partial pressure of NO2 at equilibrium. Now people, isn't there something which is going to get cancelled out? Yes. See guys, I'll take A common here, A got cancelled. So it's going to be 1 minus alpha divided by 1 plus alpha multiplied by what? Multiplied by 1.5. Multiplied by 1.5. This is basically the partial pressure of N2O4 at equilibrium. Similarly, take the A common in the denominator, A got cancelled. It's going to be 2 alpha divided by 1 plus alpha multiplied by what? Multiplied by 1.5. This is the partial pressure of NO2 at equilibrium. Well guys, I think we have got the value of alpha. Right? Value of alpha is given to me as per question. Well, if you put the value of alpha right here in these terms, it's going to be 1 minus 0.25 divided by 1 plus 0.25 multiplied by 1.5. You'll be getting the exact partial pressure of N2O4 at equilibrium. Similarly, just put the value of alpha right here in this equation, in this term, you'll be getting the partial pressure of NO2 at equilibrium. And once you get the partial pressure of reactant and product at equilibrium, what you'll be doing is you'll be simply writing the expression for Kp, and Kp expression is going to be partial pressure of NO2 at equilibrium raised by its stoichiometric coefficient, that is 2, divided by partial pressure of N2O4 at equilibrium raised by 1. Yeah, correct? So people, since I would have calculated the partial pressure of NO2 at equilibrium right here, which is 2 alpha multiplied by 1.5 divided by 1 plus alpha, and alpha value we already know, divide by alpha value, put it here again. Okay, put it here again. You'll be getting the partial pressure of N2O4 at equilibrium. right? Get the values, get the partial pressure of reactant and product, put it in this equation, get the value of Kp, right? Thank you, Preetham, thank you. Can you just let me know in the chat box if it's clear to every single guy? Can you let me know? Well, Priya is saying it is supposed to be 0.6. Is that? Is that? At the end, you're going to get it as something 0.5 divided by 0.75. Put the values, I mean, just calculate it out. That's done, you're done. Exactly, it's going to be around 0.6, yeah? Right? Perfect, perfect. Let me know. Give me the green signal so that I can move on to the next question, our next concept. Let me know in the chat box. Yeah? Should I be moving on? Should I be moving on? Well, I can see some green hearts coming up. Yeah? Okay, perfect. Perfect, guys. Perfect, perfect, perfect. Let's move on then. Let's move on to the next question right here, which is on your screen. Well, you can solve this question as well. It's a very simple and ordinary question. Yeah? I'm giving the reaction. I'm giving the percentage dissociation as 33.33%. From this percentage dissociation, you can calculate the value of alpha, which is going to be 1/3. Yeah? Well, we have the total pressure at equilibrium as 0.88. We are supposed to calculate Kp for the reaction. It's a very simple question. Just look at the solution directly. See, guys, understand. Let's assume at time t is equal to 0, I have got A moles of NOBr. So this is going to be 0. This is going to be 0 at time t is equal to 0. Correct? If alpha is the degree of ionization, if alpha is the degree of dissociation, the number of moles of NOBr left at equilibrium is going to be A minus A alpha. This is something which we already know. These are the moles A minus A alpha. These are the moles of NOBr present in the container at equilibrium. Yes. Similarly, since 2 moles are going to give 2 moles, 1 mole gives 1 mole, so A alpha moles are going to give me A alpha moles. So these are the moles of NO present in the container at equilibrium. Now use the stoichiometry again. Since 2 moles of NOBr gives 1 mole of Br2, 2 moles of NOBr gives 1 mole of Br2. So 1 mole of NOBr should give me 1/2 moles of Br2. So A alpha moles are going to give me A alpha by 2 moles of Br2 at equilibrium, right? So I got the moles of each reactant and product at equilibrium. People, can I calculate the total moles present in the container at equilibrium? Total moles present in the container at equilibrium is going to be A minus A alpha plus A alpha plus A alpha by 2. The total moles at equilibrium on just taking the sum of these terms, it's going to come as A plus A alpha divided by 2. So I got the total moles present in the container at equilibrium, which is A plus A alpha by 2. Yes. Now divide all the terms by A plus A alpha by 2. I have divided it over here. I have divided it over here. I have divided it over here. Can I say I got the mole fraction of each reactant and product at equilibrium? And once you got the mole fraction of each reactant and product at equilibrium, I'm going to multiply these mole fractions of each reactant and product at equilibrium by the term total pressure at equilibrium, PT. Yeah. And what is the value of PT which is given to me? The total pressure at equilibrium is given to me as 0.88 and alpha value is simply 1/3 because percentage dissociation is 33.33%. Yeah. Well, people, I know the value of alpha right here. Alpha value is 1/3. I know the PT value, that is 0.88. Just put these values into these terms. You'll be getting exactly the value of partial pressures of each reactant and product at equilibrium. And once you get the partial pressure of each reactant and product at equilibrium, just put it in the expression for Kp and you'll be getting the value of exact Kp. Yeah. Let me know in the chat box if it is clear to everyone right here so that I can move on to the next one. Yeah. Let me know fast, let me know fast. Let me know fast if it's clear. Perfect. Yes, I'm in Kashmir, yes. Okay, wonderful guys, great. So this is crystal clear it seems, yeah? Thank you, already prepared. Thank you. Okay, let's move on then. Let's move on. Okay, one more question right here. Well, people, before doing this sort of a question, let me make you familiar with the formula right here. Let me make you familiar with one important formula right here. Okay, what is that going to be? Understand. Let's say I've got the reaction as A gas in equilibrium with N times B gas. Let's say this is the reaction which I have, and this reaction is at equilibrium, okay? Well, you would have heard something called as calculation of degree of dissociation from vapor density measurement. Yeah, I have taught you that. If you do not remember, you can go to the playlist. You can watch the video lectures of chemical equilibrium. That was, I guess, the last session of chemical equilibrium in which I have taught this vapor density measurement. Okay. Yes. Now we will see what I'm going to write. There's a formula in order to calculate alpha. Let's assume the degree of dissociation of this reaction is alpha. So alpha is equal to capital D minus small d divided by small d multiplied by N minus 1. What is this capital D? Capital D is what I call as theoretical vapor density. Yeah, it's what I call as theoretical vapor density, or I'll be writing it as vapor density of the reactant. Vapor density of the reactant at time t is equal to 0. Vapor density of the reactant at time t is equal to 0, which is going to be equal to molar mass of reactant divided by 2. Yes, I hope you remember the formula. Molar mass is equal to 2 times vapor density. That means vapor density is equal to molar mass divided by 2. Right? So capital D is what I call as vapor density of reactant at time t is equal to 0, which is equal to molar mass of reactant divided by 2. What is small d all about? Small d is going to be the vapor density of the equilibrium mixture. Vapor density of the equilibrium mixture, okay? Or small d is what I call as experimental vapor density. Or small d is what I call as experimental vapor density. What is capital D? Capital D is what I call as theoretical vapor density. It is called as theoretical vapor density, or you can call it as vapor density of reactant at time t is equal to 0, right? Yes. Yes, Karthik, you're right. You're right. You're right. Hema, I was not well, that's why. Okay, so people, I'm sure you're clear with the two terminologies. Capital D is the vapor density of the reactant at time t is equal to 0, which is molar mass of reactant divided by 2. Small d is what I call as vapor density of the equilibrium mixture, because at equilibrium I'll be having a mixture present. I'll be having the moles of A as well as moles of B present in the container at equilibrium, due to which I'll be having the mixture of gas at equilibrium. Yes, and whatever is going to be the vapor density of that mixture of gas, that's simply represented by T, small d, yeah? And capital D, that is the vapor density of the reactant at time t is equal to 0, okay? And N is right here, this one, okay? Now guys, understand. Let's say I've got the reaction as PCl5. Let's say I've got the reaction as PCl5 in equilibrium with PCl3 gas plus Cl2 gas, yeah? The first thing, always remember, capital D will be greater than small d, okay? Always remember, every time you're going to find capital D greater than small d, okay? Remember this at the same time. Okay, in order to calculate the value of N for this reaction, what am I going to do? I'm going to check 1 mole of the reactant gives how many moles of products? Can I say 1 mole of reactant gives 1 plus 1, 2 moles of products? Right? 1 mole of reactant is going to give me 2 moles of products right here. So I can say value of N right here for this reaction is simply 2. Yeah. For example, I've got the reaction as 1 times A gas in equilibrium with 2 times B gas plus C times plus 3 times C gas. Just a second, plus 3 times C gas. Let's say this is the reaction which is given to me. Can you let me know the value of N for this reaction? Absolutely, you can do that. You're simply going to check how many moles of products are produced from 1 mole of reactant. It's going to be 2 plus 3, that's 5. So 5 moles of products are being produced from 1 mole of reactant, right? So N value right here is 5. So I hope you got to know how to calculate the value of N. Yeah. Now, let's try to approach this question. I'm given with the reaction as N2O4 gas. N2O4 gas, it's in equilibrium with 2 times NO2 gas. This is the reaction which is given to me. Correct? This is the reaction which is given to me. Well guys, few minutes back I told you the formula. Alpha is equal to capital D minus small d divided by small d multiplied by N minus 1. Okay? Well, the vapor density of NO2 and N2O4 and NO2 mixture at a certain temperature. Okay? That means the vapor density of the mixture, he's talking about experimental vapor density of the equilibrium mixture, which I'm representing by small d. It's given to me as 30. Okay, so small d value is given to me. Well, people, can you let me know the value of N? 1 mole of reactant is giving me 2 moles of products, so N value also I calculated, N value is 2. Now the point is, what is the value of capital D? Capital D is simple theoretical vapor density, or we call it as molar mass of reactant divided by 2. What is the molar mass of reactant? Molar mass of N2O4 is simply, I guess, 92. right, divided by 2, which comes out to be 46. So we have the value of capital D, we have the value of small d. You can just put the values of capital D and small d in this equation. You'll be getting the value of alpha, right? So it's going to be capital D. Capital D value is given to me as 46 minus small d is simply 30 divided by small d is 30 multiplied by n minus 1. N value I got to know as 2 minus 1. This value you'll become getting to know as 0.53. So you got the degree of dissociation of N2O4 right here at equilibrium as 0.53. If you know the value of alpha, you can simply calculate the percentage dissociation, which I believe I'm supposed to calculate, which is equal to alpha multiplied by 100. Alpha value already we know 0.53 multiplied by 100. So percentage dissociation right here I got to know as 53. So I'll say at equilibrium, you'll see 53% of N2O4 would have got converted into the product, right? Let me know in the chat box if it is clear to everyone. Let me know in the chat box if it is clear to every single guy. Let me know fast. Let me know fast if it is clear to everyone right here, so that I can move on to the next one. Yeah? Perfect. Perfect, guys. Perfect. Okay. Exactly, it's going to be 53%, yeah? So, well, I got the green signal. So, you want me to move ahead, is that? Let me have some water first. My throat is getting dry. Am I getting the green signal here? Dr. S. Parvati, I'm doing great. How are you? Thank you, Nikhil. Thank you so much. Yes, Tane, I'll be starting organic tomorrow. Tomorrow we are going to do the lecture number 10 of GOC, hyperconjugation. Tomorrow we'll finish off the GOC part 1. And then in this week only, I'll be doing hydrocarbons and chemical bonding together. Okay? Oh, you're Shri Harshni from my long-term batch. Welcome to the session. Perfect. Let's move on to one more question, guys, which is on your screen right now. Well, this is one nice question and simple at the same time. See, in the reaction, the vapor density of the mixture is reduced to half when equilibrium is achieved. Vapor density of the mixture, that means he's talking about small d, yeah? It is reduced to half. Half of what? Half of initial vapor density, which is at time t is equal to 0, that's capital D. So what is mentioned in the equation? As per the equation, small d is equal to capital D divided by 2. Done, yeah? This is something which I got to know from the first statement, okay? If the degree of dissociation, well, it should be percentage dissociation. It should not be degree of dissociation. It should be percentage dissociation, right? If the percentage dissociation is 25, that means degree of dissociation is going to be equal to percentage dissociation divided by 100. That is 25 by 100, which comes out to be 1 by 4, yeah? Calculate how many moles of B will be formed at equilibrium on starting with 2 moles of A. Okay, see guys, the reaction which is given to me is A gas in equilibrium with N times B gas, yeah? This is the reaction, I believe, A gas in equilibrium with N times B gas. Now we will understand how do we do this. See, first thing, I can write alpha is equal to capital D minus small d divided by small d multiplied by N minus 1, okay? Well, we will the value of alpha, already we know that is 1 by 4 is equal to capital D, I'm writing as such, small d is equal to capital D divided by 2, small d is equal to capital D divided by 2 multiplied by N minus 1. Can I say d minus d by 2, that means d by 2 got cancelled. So I got something as 1 by 4 is equal to 1 divided by N minus 1, or you can calculate the value of N from here, it comes out to be 5. So the value of N right here is equal to 5. Value of N right here is equal to 5, okay? Well guys, if you got to know the value of N, you can write the complete reaction like this, A gas in equilibrium with 5 times B gas, yeah? This is the reaction, this is the complete reaction which you got. Now what am I supposed to calculate? I'm supposed to calculate the moles of B which have got formed at equilibrium on starting with 2 moles of A, yeah? So basically, I'm starting with 2 moles of A. I'm starting with 2 moles of A. This will be 0 at time t is equal to 0. Let's assume degree of dissociation is alpha, which we already know alpha is equal to 1 by 4. So can I say at equilibrium, it is going to be A minus A alpha. Since 1 mole gives 5 moles, so A alpha moles are going to give 5 times A alpha moles. So I got the number of moles of B at equilibrium equal to 5 times A alpha. I know the value of A, which is 2. I know the value of alpha, which is 1 by 4. So the value is going to be 2.5. So 2.5 moles of B would have got formed at equilibrium. Yes, which I was supposed to calculate. Let me know in the chat box if it's clear. Yes, Ruchi, you can do that. You can do that. You can do that. You have got a lot of time. 3 months are enough. 3 months, trust me, 3 months are enough. If you'll just follow your NCRT in all the subjects, you are going to kill it. Trust me on that. Let me know in the chat box if it's clear to everyone so that I can move on to the next one. Yeah? Perfect. Perfecto. Okay. Well, the green signal I got. Yeah? Green signal I got. Nikhil, I have no idea like how many questions are there. Let's try it. Let's see. Okay, let's move on to one more question, guys. This is one more question, a conceptual question this is, okay? 1.1 moles of A are mixed with 2.2 moles of B, and the mixture is kept in a 1 liter flask till equilibrium is achieved. Okay. At equilibrium, 0.2 moles of C is formed. The equilibrium constant of the reaction Kc. So basically, we are supposed to calculate the value of Kc for the reaction. Hi Faisal, how are you doing? Okay, see guys, I'm giving the reaction as A plus 2B in equilibrium with 2 times C plus D. This is the reaction which is given to me, okay? Perfect. And I'm assuming all the A and B are present in the gaseous state, okay? At time t is equal to 0, when the reaction has not started, I'm given with 2.2 moles of A, is that? No, 1.1 mole of A. At time t is equal to 0, I'm given with 1.1 mole of A. I'm given with 2.2 moles of B. So this is going to be C and D. Is there C and D mentioned? No. That means C and D is going to be 0 at time t is equal to 0. So I'm starting with 1.1 moles of A and 2.2 moles of B. Okay. So at time t is equal to 0, there will be no C, no D in the container, right? Well, the volume of the container is 1 liter. So whatever will be the moles of reactant and product at equilibrium, same is going to be the concentration of reactant and product at equilibrium, because we know concentration is number of moles divided by volume. Since volume is 1 liter, so whatever is going to be the concentration, same is going to be the moles. Whatever is going to be the moles at equilibrium, same is going to be the concentration, yeah? Perfect. Now guys, it's mentioned in the equation, at equilibrium 0.2 moles of C are formed. So at equilibrium 0.2 moles of C have been formed. This is something which is mentioned, okay? Now, how do we approach this? At equilibrium, 0.2 moles of C have got formed, okay? See guys, if I use the stoichiometry, understand, if I use the stoichiometry, can I say 2 moles of C have got formed from 2 moles of B? So 1 mole of C would have got formed from 1 mole of B. So 0.2 moles of C would have got formed from 0.2 moles of B. So I can say out of 2.2 moles of B, 0.2 moles have reacted basically with A, right? So I'll be left with 2 minus 2.2 minus 0.2, right? So I got to know out of 2.2 moles of B, 0.2 moles of B have reacted with A, okay? Now understand, since 2 moles of B react with 1 mole of A, so 1 mole of B will react with 1 by 2 moles of A. So 0.2 moles of B would have reacted with 0.2 divided by 2, that is 0.1. So out of 1.1 mole of A, 0.1 mole of A have reacted. So I'll be left with 1.1 minus 0.1 mole of A at equilibrium. I hope this is clear to everyone. Yeah? I got the moles of each reactant and product right here at equilibrium. Can you let me know? Did you guys get this part? Did you guys get how I got these terms? Yeah? Let me know in the chat box fast so that I can move ahead. Did you get it properly? Can you just let me know in the chat box, did you get it properly? Everything you need, you can just drag the video a little back. Just drag the video a little back. It'll be automatically a replay. Perfect, Karthik. Yes. Wonderful. Well, Mavish, just drag the video a little back. It'll be automatically a replay. Now, guys, understand. Since 1 mole of A gives 1 mole of D, so I can say 0.1 mole of A gives 0.1 mole of D. Just normal stoichiometry I'm using. That's it. Yeah. 1.1 minus 0.1 means simply 1. 2.2 minus 0.2 means simply 2. This is going to be 0.2. This is going to be 0.1. I got the moles of each reactant and product at equilibrium, right? Since the volume of the container is 1 liter, so whatever is going to be the moles of reactant and product at equilibrium, same is going to be the concentration of reactant and product at equilibrium, right? Because volume of the container is 1 liter. Well, guys, you can simply write the expression for Kc right here. It's going to be concentration of C at equilibrium raised power 2 multiplied by concentration of D at equilibrium raised power 1 divided by concentration of A at equilibrium raised power 1 multiplied by concentration of B at equilibrium raised power 2. So concentration of C at equilibrium, that is 0.2 square. It is 0.2 ka square multiplied by concentration of D at equilibrium, that is 0.1 ka square. It's not square, it's raised power 1. Yeah, divided by concentration of A, that is 1 raised power 1 multiplied by 2 raised power stoichiometric coefficient, that is 2. Correct? Just solve it. You'll be getting the value of Kc, which you were supposed to calculate. Okay. Let me know in the chat box if it is clear to everyone. Let me know in the chat box if it is clear to every single guy right here. Let me know in the chat box with the thumbs ups. Okay, perfect. Perfect, guys. Perfect. Let's move on. Okay, the correct option you're getting is option C. I'm sure this is clear to everyone now. Right? Perfect, guys. Okay, this is one simple question which you all can solve on your own. I believe that. Okay. Well, I hope you remember the relation between Kp and Kc. Kp for this homogeneous gaseous phase reaction is equal to Kc RT to the power delta Ng, right? Yes. I need to get the value of Kp divided by Kc. So Kp divided by Kc, this is the general expression, I hope you remember, is going to be RT raised power delta Ng. Well, guys, do I know the value of delta Ng? I can calculate it. Yes. Delta Ng is simply going to be equal to number of moles of gaseous products, that's 1, minus number of moles of gaseous reactant, which is 1 plus 1, that is 2. So 1 minus 2 is simply minus 1. Yeah. So it's going to be Kp divided by Kc is equal to RT raised power minus 1. Is there any option satisfying that? Kp divided by Kc is equal to RT raised power minus 1. That means 1 by RT. Option A is supposed to be the one. Yeah. Is that clear to everyone? Let me know in the chat box. Exactly. Exactly, guys. The value of Kp by Kc is going to be RT raised power minus 1. Right? Perfect. Let's move on to one more question right here. And people, this is going to be the last question of the today's session. And I have come up, there are few more questions which I'll be showing it to you, but those are very simple. You guys can do them on your own, okay? And you'll be getting the PDF of this session in the Telegram group as well. So do give those questions a try on your own and let me know in the next session, that means tomorrow, if you could do them or not, okay? See, in which of the following equilibria Kp is not equal to Kc? It's again a simple question, right? What is the relation between Kp Kc, right? It's going to be Kp Kc RT raised power delta Ng. Any reaction in which delta Ng is not equal to 0, any reaction in which delta Ng is not equal to 0, in that reaction Kp will not be equal to Kc, right? In that reaction only Kp will not be equal to Kc. I think there is only one reaction, that is reaction number 1, in which delta Ng is non-zero, in which delta Ng is equal to 1. So that means in the first reaction itself, if delta Ng is equal to 1, if delta Ng is non-zero, for this reaction Kp is not going to be equal to Kc, right? So option A is the one in which Kp is not equal to Kc. Rest in all the other cases, you could see delta Ng is equal to 0 for all the three reactions. If delta Ng is equal to 0, you can say clearly Kp is equal to Kc, yeah? Well, guys, from tomorrow, the timing is going to be 7:30 in the evening, okay? Well, let me show you few more questions. These questions you guys are going to give it, or let me show you this question right here. It's a nice question, I believe. See, guys, the relation between Kp and Kc is Kp is equal to Kc RT raised power delta Ng. Okay, what is this R right here? R is gas constant, right? Its value in atm liter per Kelvin per mole is 1 by 12, right? Correct? R value is 1 by 12. I hope you know this. Kp is equal to Kc. Instead of R, I can write 1 by 12 multiplied by temperature. This is delta Ng. Okay. Well, I'm giving you the reaction. 2 times NO2 gives 2 times NO gas plus O2. First thing, calculate the value of delta Ng for the reaction. The value of delta Ng is 2 plus 1, 3, 3 minus 1, 3 minus 2, 1. So delta Ng value is given to me as 1, right? Now, Kc is also given to me something, and temperature is given to me as 184 degrees centigrade, right? 184 degrees centigrade, correct? So is the temperature right here greater than 12 Kelvin? Yes, the temperature is greater than 12 Kelvin. Why am I telling you that? If the temperature is greater than 12 Kelvin, if the temperature is greater than 12 Kelvin, then only this whole term is going to be greater than 1. If the temperature is greater than 12 Kelvin, then only this term is going to be greater than 1. Yes. And if this term, since I got to know temperature is greater than 12 Kelvin, right? I got to know temperature is greater than 12 Kelvin. I can say this whole term is greater than 1. And this greater than 1 term, let's keep it as, for instance, let's keep it as 4 something, right? It is Kp is equal to Kc multiplied by, since this term is greater than 1, let's keep it as 4 in general. I mean, let's assume that raised power delta Ng, correct? What is the value of delta Ng for the reaction? Delta Ng for the reaction is not, it's 1, right? Delta Ng for the reaction is 1. It's 2 plus 1, 3, 3 minus 2, 1, right? So if delta Ng is 1, can I say Kp is equal to 4 times Kc right here? Okay, so which option satisfies it? I can say Kp is greater than Kc 4 times, right? Yes, I can simply say Kp is greater than Kc. So which option is satisfying this? Kp is greater than Kc, right? Now people, if temperature was not greater than 12 Kelvin, if temperature was not greater than 12 Kelvin, let me show you that case as well. I'm going to show you that case as well. If temperature was not greater than 12 Kelvin, I'm assuming if temperature was less than 12 Kelvin. If temperature was less than 12 Kelvin, then this term would have been less than 1. Okay, I'm assuming Kp is equal to Kc, and this term is less than 1. Let's keep it as 0.5 raised power delta Ng. 0.5 raised power delta Ng. Delta Ng is greater than 1. So at that time, Kp would have been equal to Kc multiplied by 0.5, or Kp would have been equal to 0.5 times Kc. That means at that time, Kp would have been less than Kc. Okay, so it entirely depends on temperature, what you are checking exactly. Okay. If temperature in the question is greater than 12 Kelvin and you have got the reaction whose delta Ng is greater than 0, at that time Kp is greater than Kc, yeah? And at the same time, if I'll be having a reaction whose delta Ng is greater than 0, but at the same time temperature of the reaction is kept less than 12 Kelvin, at that time Kp will be less than Kc, yes? Let me know in the chat box if the concept is clear. Let me know. Yashwant, I'm doing great, how are you? Let me know in the chat box if it's clear. Satindra, I'm great. I'm doing great. I'm doing great. Perfect. Perfect, guys. Now there are some questions. Look at these questions. Okay, one more simple and basic question. Equilibrium constant for the reaction is, it's a very simple question, guys. We are supposed to get the value of Kp. This is in solid state, this is in solid state, this is in gaseous state. The active mass of solids is taken as constant, and that constant is equal to 1. I hope you remember. Yeah. So Kp expression is simply going to be equal to partial pressure of carbon dioxide at equilibrium raised by its stoichiometry coefficient, that's 1. Rest all the other things are in solid form. Their active mass are constants. That constant is equal to 1. So Kp value is going to be partial pressure of carbon dioxide. Which one is that going to be? It's going to be the first one, yeah? Right? Perfect. Let's move on to one more question. This is something I believe which you can easily solve this one, okay? This is something which you can easily solve. I have shown you the concept. I've given you the concept of this question, right? Well, this is one more similar type of question. You are going to try it out. You're going to try it out on your own. And I have mentioned the solution as well. And those solutions you can get in the Telegram group once after the session ends. Okay, this is one more similar type of question. You can give it a try again. Let me know. This is one more similar question. These are, I guess, 7 to 8 questions which are going to be your homework right here. Okay, this is the Le-Chatelier principle. Can you let me know the answer of this one? Just by looking at the question. Just by looking at the question. Just by looking at the question. Can you let me know the answer of this one? Just by looking at the question. Reaction BaO2 solid in equilibrium with BaO solid plus O2 gas, delta H is positive. In equilibrium condition, the pressure of O2 depends on. The pressure of O2 depends on. What do you think? What do you think? In equilibrium condition, he is asking about in equilibrium condition, pressure of O2 depends on. Does pressure of O2 at equilibrium depend on the increase in the mass of BaO2, the increase in the mass of BaO, the increase in the temperature on equilibrium, increase in the mass of BaO2 and BO both? Since your BaO2, BaO both are in solid form, their active masses are unity, okay? They are not going to contribute towards any sort of pressure at equilibrium, right? They're in solid form, their active mass is unity. They are going to show no contribution towards the total pressure at equilibrium. Whatever will be the pressure of the container at equilibrium, that's entirely going to be due to O2, okay? Okay, so increase or decrease in the masses of BaO2 or BaO2 is not going to affect the total pressure of the system at equilibrium. That means total pressure of O2 at equilibrium. So there is only one thing, that is increase or decrease in the temperature can change the pressure of the system at equilibrium, can change the total pressure of, pressure of O2 at equilibrium. I hope you got it, yeah? Right? Jaran, the timing of class from tomorrow is going to be 7:30, okay? From 7:30, I'll be starting the session sharp. Yes, Faisal, you can take the session on. Well, guys, one more thing. Tonight at 10:30 p.m., I'm coming live on Vedantu JEE English channel, which we call as VJ Enthuse. And today, I'm going to do the 0 to Hero series of chapter Thermodynamics on Vedantu JEE Enthuse channel. You all can join in at 10:30 sharp. Okay. Well, I guess this was it for today. Well, for the ones who have no idea about the NEET 2021 crash course, let me give you the brief idea about it. What all benefits you guys will be getting if you'll enroll yourself in NEET 2021 crash course? Well, the first and important thing, you are going to get trained by the teachers of your choice. Number one, we are going to cover your whole syllabus, okay, on the actual Vedantu platform, right? And by the teachers of your choice, right? Well, no need to worry about the test series. Okay, no need to worry about the mock tests. Everything is included in this NEET 2021 crash course. And at the same time, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers. They'll be available for you 24/7. And at the same time, there'll be some extra sessions regarding the tips and tricks of how to solve the questions in lesser time. Okay, there'll be some extra sessions regarding the time management. Everything right here is included in this NEET 2021 crash course as a package. Okay, so do get enrolled in this one. It's my personal suggestion for you guys to get enrolled in this one. It's definitely going to shoot up your performance by 50 to 60 marks. Trust me on that. I'm telling you that, okay? If you enroll in this, it's going to shoot up your marks in NEET 2021 by 50 to 60, okay? I guarantee you that. Okay, and how to get enrolled in this? You just need to click on the Vedantu app. After clicking on the Vedantu app, just click on the NEET 2021 crash course. After clicking on the NEET 2021 crash course, just use the coupon code WSNEET. On using this coupon code of WSNEET in capitals, you'll be getting me as your chemistry teacher, okay, in the NEET crash course. And at the same time, you're getting the 30% off. And after the off, you're just getting this crash course for 7K, which includes the complete course, complete syllabus completion. And at the same time, extra sessions regarding the time management, tips and tricks with the experts, by means of which you can solve the questions in lesser time. Right? So do not forget to use this coupon code as WSNEET if you want me to train you personally for your upcoming NEET 2021 or the 2022, right? So people, there's a link in the description box of the video as well. You can click on the link, get added, okay, get added the crash course, and let's shoot the bullseye together. There is one more link in the Telegram group, which is there in the description box. Do click on the link, get added to the Telegram group, and stay updated about the classes. And at the end, for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions. Well, people, yes, Malum, I'll be doing that as well, no issues. So people, from tomorrow at 7:30, I'll be coming live, okay, on this NEET Lead channel. So do not forget to attend the sessions from tomorrow. And tonight, I'll be coming live on Vedantu JEE English channel at 10:30. You can join in, wherein I'll be doing the same type of series, Zero to Hero series from the chapter Thermodynamics. So do not forget to attend that as well. It was nice meeting you after so long. I'm sure you would have enjoyed this session. So with this, I need to sign off from here. See you guys tomorrow on the same channel. Till then, you can take care. Bye-bye. God bless you all. Love you all. Bye, guys. Take care.